Okay, welcome back for our next installment. In this lecture, we're going to be looking at prefixes and equalities. So certain things you'll have to commit to memory in terms of prefixes, and then equalities will have some that will be available for you and others that you'll have to commit to memory, and I'll just let you know which is which. And I didn't mean to scare you there. I think most of you have most of these prefixes memorized already from prior coursework, and I think you've probably at least seen a lot of the equalities, so it shouldn't be any cause for concern, and certainly get in touch with me if you do have concerns about any of the prefixes or equalities that we'll be discussing. Prefixes, you've probably heard this term many times. Probably way back in elementary school you first learned about a prefix. And in science, the prefix is in front of a unit typically to increase or decrease the size of that unit relative to the base unit. So because we're doing things in metric and in System International, SI units, typically everything's going to be some form of a factor of 10, maybe just a factor of 10, maybe a factor of 1,000, but some multiple of 10. And it gives a numerical value. So if we look at the prefix 1 kilometer, or kilometer if you prefer, is 10 to the third, or 1,000 meters. So the base unit doesn't have any prefix meter. Kilometer, that prefix of kilo means 1,000 times. Centi, on the other hand, means 100. So centimeter, 1 centimeter would equal 0.01 meters, so on and so forth. Terabyte, you probably have a better handle on prefixes than any other generation, because now you know about terabytes and gigabytes and megabytes from your computer backgrounds. Hopefully you've had a little bit of experience with that, and you would know that tera means 10 to the 12th, because a terabyte is 10 to the 12th bytes. Of course, you can have a terameter, which would be 10 to the 12th meters. We just happen to use the computing terminology that's probably more familiar to you if you look at hard drives in terms of terabytes, for instance. Table 1.8 here shows a number of different prefixes, peta or peta, depending on how you pronounce that one. That's the next one up from tera, so that's probably where you'll see computing in the near future. Is going to be 10 to the 15th. Right now, tera, 10 to the 12th, is about where hard drive sizes are. Giga, 10 to the 9th. Mega, 10 to the 6th, or 1 million. And then kilo, 10 to the 3rd, or 1,000 times. Those tend to be the main ones we would use for large numbers that require a prefix to indicate a much larger unit than the base unit would be. Now here in this table, we see prefixes that result in a smaller size than the base unit. So deci, centi, milli, that's 10 to the minus 1, 10 to the minus 2, and 10 to the minus 3. And then we tend to jump in larger intervals. So micro is 10 to the minus 6, nano is 10 to the minus 9, pico is 10 to the minus 12, and femto is 10 to the minus 15. So pretty much the same sorts of values that we looked at in the previous table, only now 10 to a negative exponent instead of 10 to the positive exponent. So if we're looking at a given reaction or an electron transfer process, it might happen on the order of femtoseconds. So it's a very fast process, so it's a very short unit of time. Whereas if we looked at the previous slide for things like number of atoms, maybe we have, a tera-atom, 10 to the whatever, 12th or 15th number of atoms to get something reasonable in terms of a measured unit. So in chemistry, we deal with very small things, so we need the small prefixes, and we also tend to deal with very large numbers of those small things, so it's important we understand the larger prefixes as well. So these are the prefixes that you see on the table are the ones that I would expect you to know offhand. So be able to tell me that deci's 10 to the minus 1, for instance, or nano's 10 to the minus 9. So hopefully you've got a handle on that already, but if not, the ones we tend to use tend to be nano, micro, milli, centi, deci, and then kilo on the other side. Okay, those are the most common, but you should know these several prefixes and what they stand for in terms of base units. Well, why does this matter? Looking at table 1.9, we can see some of those units represented, right? Different vitamins we require different amounts of. So vitamin B12, for instance, it's a 6 microgram daily recommended value. Compare that with vitamin C, which is a 60 milligram value, or calcium, which is 1,000 milligrams. So depending on the particular nutrient, we may have much larger or much smaller requirements, and things that we need very little of can be problematic if we get too much. Even something that we need 1,000 milligrams or a gram a day of calcium, for instance, if you take in more than that, significantly more than that, you might increase your risk for things like kidney stones, for instance. So more is not always better. Certain things we have vitamin or nutrient deficiencies because we're not getting enough, but you have to be careful because you can very easily go from deficiency to toxicity since we require such little amounts of these substances. If we get more than we need for several of them, the fat-soluble type in particular, we can run ourselves into trouble just like getting too little of them. Alright, so let's pause a moment. We'll take our learning check and see how we're doing with the idea of prefixes and units. So indicate the unit that matches the description. Number 1, a mass that is 1,000 times greater than 1 gram. Is that A, a kilogram, B, a milligram, or C, a megagram? Number 2, a length that is 1/100th of 1 meter. Is that a decimeter, a centimeter, or a millimeter? And finally, a unit that is 1/1000th of a second. Is that a nanosecond, a microsecond, or a millisecond? So if you haven't already decided on answers to 1, 2, and 3, please pause the video while you do that, and then we'll pick up with the response. Okay, so hopefully for number 1, you picked a kilogram. Kilo is the prefix that means 1,000 times. So 1,000 times greater than 1 gram would be 1 kilogram. Or number 2, a length that is 1/100th of a meter. Well, centi is the prefix that indicates 1/100th. So a centimeter is 1/100th of a meter, and if you have a meter stick, it probably is divided into 100 centimeters. Finally, number 3, a unit of time that is 1/1000th of a second. Well, that would be a millisecond, right? Milli is the prefix meaning 1/1000th. So if you're struggling with those, please try additional questions at the end of the text. If you did well on those, let's see how you do on another learning check. Alright, so here we're going to select the unit that you would use to measure a variety of items. So number 1, your height. Would that be in A, millimeters, B, meters, or C, kilometers? 2, your mass. Would that be in A, milligrams, B, grams, or C, kilograms? Number 3, the distance between 2 cities. Would that be measured in A, millimeters, B, meters, or C, kilometers? And number 4, the width of an artery. Is that best measured in A, millimeters, B, meters, or C, kilometers? So go ahead and decide on the best answer choice for each of those, and pause the video if you need another moment. Otherwise, we'll check on how you did. Alright, so hopefully for number 1, you selected B, meters, the base unit. Meter is just over 3 feet, so for height, that makes the most sense. Number 2, your mass should be C, kilograms. 1 kilogram is about 2.2 pounds, so that's the most appropriate for the mass of a human being. Number 3, the distance between 2 cities, that would be C, kilometers. We need 1,000 meters. We're again over 3,000 feet there to get that distance. And number 4, the width of an artery, this would be A, millimeters. Arteries are not very large items, and millimeters, 1/1000th of a meter, would be the most appropriate unit there. So hopefully you're doing well. If not, as I said, try some additional questions at the end of the chapter, or get in touch with me for some additional guidance here with metric prefixes. Now, within the metric system, we also have equalities that you should be able to determine based on your knowledge of the metric prefixes and the base units. So, like any equality, a metric equality would state the same measurement in 2 different units, and therefore we can use this as a conversion factor to relate between 2 metric units. So for instance, 1 meter is equal to 100 centimeters and also equal to 1,000 millimeters. And so I wouldn't expect you to need to have that information given. Because you know your prefixes and because you know your relationships, I would expect you to be able to convert in between metric equalities. If you were going between the English system and the metric system, for instance, where we were looking at something like 1 inch equals 2.54 centimeters, that I would provide. That's an equality that I would give you so that you would be able to relate those two dissimilar units. But within the metric system, these equalities are quite easily understood as long as you have the prefixes down pat, and so we wouldn't worry so much about equalities within the metric system. Those you would be able to generate. Okay, so if we look at measuring something like length, we have, of course, the meter, which we said would be the most appropriate for humans, but there's also the decimeter, the centimeter, the millimeter. We could talk about any of those units as well. They're just the base unit times the metric prefix. So the metric length of 1 meter is the same as 10 decimeters, 100 centimeters, and 1,000 millimeters. So how many millimeters are in 1 centimeter? Well, if there's 100 centimeters in 1 meter and 1,000 millimeters in 1 meter, there must be 10 millimeters in 1 centimeter. We differ by a factor of 10, and we see that up above. If you look at the large image of the ruler, we've got the each of those little demarcations is a millimeter, and 10 of them would make a centimeter. Now, measuring a dimension like volume, now we're not talking about just a single unit like a meter or a centimeter. We're talking about a volume that's three-dimensional. Therefore, we'll have cubic centimeters or milliliters or cubic meters, depending on how large the object is. So if we look at this image, you're seeing that the volume there is 10 centimeters by 10 centimeters by 10 centimeters. It's a perfect cube on the left there. And so 10 times 10 times 10 is 1,000. Centimeter times centimeter times centimeter is a cubic centimeter. And this is where students tend to make mistakes. You're multiplying both the number and the unit. Don't forget to change the unit. I can't tell you how many times I've seen volumes in centimeters, and of course that's incorrect. Centimeter cubed or a milliliter, those happen to be equal. 1,000 centimeters cubed equals 1,000 milliliters, which equals 1 liter. So the volume there is 1 liter. If we look on the right-hand side, we see the syringe with 1 cc or 2 cc's. Well, that's a shorthand notation for cubic centimeters. It's often used in the medical setting. If you watch these emergency room drama shows, they'll often call for 2 cc's of epinephrine stat or some other bad science example. And so, again, a cc is a cubic centimeter. We tend to deal with liquid volumes in milliliters. We tend to use cubic centimeters for volumes of solids, like that cube on the left. For a liquid volume, like you would use for a syringe, or a gas volume, like you would also be able to do in a syringe, we tend to use milliliters instead of cubic centimeters. Even though they're equal and interchangeable, that's the tradition, is to use cubic centimeters for solids and milliliters or liters for liquids and gases. Okay, so finally, measuring mass, the last dimension that we'll talk about here in this sub-chapter, we have several different equalities that can be written for mass in the metric system. So back several slides, we talked about the kilogram as the appropriate measuring amount for a mass of a human being. And of course, 1 kilogram equals 1,000 grams equals 10 to the 3 grams. Those are all equalities. 1 gram equals 1,000 milligrams equals 10 to the 3 milligrams, all equalities as well. And therefore, we could also go the other way. If we say that 1 gram is 1,000 milligrams, well then 1 milligram would be 1,000th of a gram, or 10 to the minus 3 grams. And if we want to look at the milligram as being a larger unit, well, let's look at how a milligram relates to a microgram. 1 milligram equals 1,000 micrograms, or 10 to the positive 3 micrograms. So you have to be very careful with your units and very careful with the prefixes and how they relate to one another. Sometimes milli is a very small thing if we're comparing, say, milligrams to kilograms. Sometimes milligram is a large thing if we're comparing that to, say, micrograms or nanograms. So it's all relative, and it's important that you first get a good handle on those prefixes and then understand the relationships for those units and units with prefixes versus base units so that you can interrelate and look at equalities. Alright, so let's follow up with a learning check, as we often do toward the end of each of these videos. For this particular learning check, indicate the unit that completes each of the following equalities. So number 1, 1,000 meters equals A, 1 millimeter, B, 1 kilometer, or C, 1 decimeter. Number 2, 0.001 grams equals 1 milligram, 1 kilogram, or 1 decigram. Number 3, 0.1 seconds equals A, 1 millisecond, B, 1 centisecond, or C, 1 decisecond. And finally, number 4, 0.01 meters equals A, 1 millimeter, B, 1 centimeter, or C, 1 decimeter. So go ahead and select the best answer choice for each of those. If you need to pause the video, please do so now. Otherwise, we will move right ahead. Alright, and looking through, we've got number 1, 1,000 meters equals B, 1 kilometer. Kilo is the prefix for 1,000 times. For number 2, 0.001 grams equals A, 1 milligram. Milli, the prefix for 1,000th of whatever the base unit is. Number 3, 0.1 seconds, well, that's C, 1 decisecond. Deci, the prefix for 1/10. And finally, number 4, 0.01 meters equals B, 1 centimeter. Centi, of course, the prefix for 1/100th. So hopefully that was very easy for you. Again, if you continue to struggle with these after you've tried end of chapter questions and your homework set, please reach out to me. Let me know how I can help so that it doesn't continue to be a stumbling block for you. Okay, let's do one more learning check. Complete each of the following equalities here. Now there's just 2 questions for you to look at. 1 kilogram equals A, 10 grams, B, 100 grams, or C, 1,000 grams. And number 2, 1 millimeter equals A, 0.001 meters, B, 0.01 meters, or C, 0.1 meter. So go ahead and make your best pick for each of those, and we'll see how you did. Pause the video if you need to. Otherwise, let's look at the correct answers. Alright, and hopefully you recognize kilo, meaning the prefix for 1,000 times, so 1 kilogram is equal to C, 1,000 grams. And notice we can look at it either way. We can say that 1 kilogram equals 1,000 grams, or we could say that 0.001 kilograms equals 1 gram. We can approach from either direction. Hopefully you're feeling more comfortable with that. For number 2, 1 millimeter equals A, 0.001 meters. And again, that's just the flip side of what we looked at previously, where we had 1,000 millimeters equals 1 meter. We've got to be comfortable with those equalities. We may need to use them in different ways to solve different problems. So hopefully you're getting more and more comfortable, not only with what the prefixes mean, but also with how those prefixes and base units can be used to determine equalities within the metric system. All right, well, as I said, if you're having trouble with this, please don't just ignore it. Let's get it taken care of. If this is all coming back or coming to you for the first time very easily, then consider yourself lucky, and hopefully that will continue into our next topic.